Last year, a bunch of retro and vintage YouTubers got together and raised over £10,000 for charity. Let's see if we can do even better this year. Once again, we're working together to raise funds for the Befriending Scheme, an organization that makes it possible for vulnerable individuals to meet up, form friendships, and participate in social and learning activities. Let's hear more from the organizer of this event, Lee of More Fun Making It.
Hi, I'm Lee from the YouTube channel More Fun Making It, and this year I'm raising money for the Befriending Scheme. The Befriending Scheme is an organisation that provides friendship and learning opportunities for vulnerable adults across Suffolk here in the UK. My own son Thomas enjoys working at the Red Rose Community Farm, run by the scheme, where he's able to build and maintain friendships as well as learn useful skills and engage in meaningful activities. He especially loves to care for the many animals on the farm, but I suspect his favourite thing is hanging out with his friends. The money we aim to raise this year will be used to fund acquiring some miniature donkeys to live on the farm. That's right, donkeys come in mini size too. On the 19th of October, I'll be hosting a 12-hour live stream with lots of retro and vintage tech YouTubers from all over the world. And during the day, all of the auctions I and others have been preparing will be ending, hopefully raising a huge heap of money to buy those donkeys. The theme of this year's event is Commodore, and we'll have lots of different Commodore machines ranging all the way from the Kim 1 right up to an amazing Amiga 1200 in a big box Checkmate case. As well as all the stuff I'll be selling, lots of my YouTube chums will be auctioning off their own items, with all of the proceeds going to the cause. And I suspect the video you're watching right now is all about one of those items. So if you'd like to bid on something or just come along and watch the stream, you can find links to everything you need in the description. If you can't make it but would like to donate, there's a Just Giving page which you can find in the same place. Thank you, and on with the video.
Thanks, Lee. As you just heard, vintage and retro YouTubers from all over the world will be participating by holding auctions with all the proceeds going to benefit the Befriending Scheme. As this year's theme is Commodore, here's one right now. In today's video, we're going to get it repaired and restored in order to auction it off for this wonderful cause. In a few days, I'll be joining Lee on his channel for the 12-hour live marathon, so turn on notifications and be on the lookout for that announcement. And also make sure you're subscribed to More Fun Making It if you haven't already. And here it is, a C64 bread bin that I purchased untested at VCF Midwest a few weeks ago. It looked really cool with this integrated keyboard cover, and it seemed like it was in really good condition. I didn't know I was going to be participating in this charity auction at the time, so it's a good thing I'm unable to walk by a bin of untested 64s and not buy at least a couple. In terms of physical condition, the machine is in really good shape. There's no cracks or damage to the plastic anywhere. There's no discoloration. So it looks like it was cared for pretty well by its past owners. One thing that is interesting is inside the keyboard cover, there's a fair amount of dust here, which makes me think that during its service lifetime, this may have been left open more than it was left closed. There's also a fair amount of debris and dirt built up here in the cracks and crevices, but we'll get this all cleaned up really nice for the new owner who bids on the auction. On the underside, we have all 4 of the rubber feet still in place, and all 3 of the screws are still there. Also, we have these little adhesive double-sided foam strips. I have no idea what these could have been used for. If anybody knows what might have been stuck here on the underside, do let me know in the comments. I'm curious to know what these might have been for.
I was initially drawn to this machine because of the unique hinged keyboard cover. The ones I've seen in the past were either cloth or plastic shells that got removed entirely before use. I wanted to find more information on this product, but was unable to locate any marketing literature in old computer magazines. I did learn that Comptermate was an Australian company founded in 1984 that expanded into the US and UK markets the following year. They sold software and accessories, including things like storage containers, dust covers, and monitor stands for Commodore, Atari Amstrad, and IBM computers.
One thing I thought was interesting was with the cover open, there's this little tray here, and it's clearly been designed to store things because it's really not necessary for structural integrity or anything like that. I'm not sure what they had in mind, but you can certainly store some small stuff like a writing implement or maybe a tiny screwdriver. Maybe you can store some candy for in case you get hungry. Okay, no, candy won't fit, but you can certainly store some other small, long objects in there like that. I'm not really sure what they had intended it for, but I thought that was kind of neat. All right, time to get this thing connected up so we can test it. I'm going to hook up the video output to my capture device, and we're going to connect power here. Let's flip over to the video capture screen, and I'm going to flip the power switch. There we go. We've got the red LED, and we've got a black screen. Zoom in on that a little bit here. Yep, a traditional Commodore 64 dead black screen with nothing on it, no garbage, no color, nothing, just a white line running down the side of the screen. That's pretty typical. So yeah, often when you buy an untested Commodore, that is code for broken, at least on eBay. But in this case, I believe the seller really hadn't tested them, as he had a whole pile of machines for sale, and you know, I actually bought 2 from that pile, and the other one worked fine, but that's boring and doesn't make interesting content, so we're gonna fix this one instead. So just as a little aside, I was at VCF Midwest a few weeks ago, as I mentioned, and I was chatting with a gentleman named Matt, and he had brought up the fact that he was working on a new Commodore 64 dead test cartridge that improves upon the old original Commodore dead test in many ways. And I'd been chatting with him for 5 or 10 minutes before I realized the person I was actually talking to was, in fact, Matthew Desmond. Now, a lot of you hardcore Commodore users will remember that name, as Matthew Desmond is the guy who created DesTerm for the Commodore 128, which was the preeminent terminal program back in the day, and something I used all the time as a kid. So it's not every day that you get to meet one of your childhood Commodore heroes, so that was really cool and unexpected, and something that only happens at a venue like VCF. Anyway, after a long hiatus, Matt is back in the Commodore scene, and what he's working on is the DesTestMAX. And what this project aims to do is to improve upon the Commodore dead test cartridge by using a more comprehensive memory test strategy and providing easier to interpret diagnostic output. So where the original Commodore dead test could just flash the screen white a number of times to indicate where it found a bit error, the DesTestMAX displays much more human readable information on the screen even when the machine itself is unable to boot. So by using some clever programming tricks, it can test multiple bit errors and display them using border colors all at once on a single screen, which gives you a very clear indication of what's going on with your machine if there's a failure. Now, Adrian's Digital Basement did a much more comprehensive video about the DesTestMAX than we're going to be able to do today, so check that out if you're interested. But we are going to use this cartridge in order to try and troubleshoot our dead C64 today. All right, I'm going to insert the DesTestMAX cartridge into the slot here. Now, I've already tested the cartridge on a working machine, so I know that the cartridge works fine. We're going to flip the power on, and nothing. Okay, so the DesTestMAX should display something on screen immediately, unlike the dead test, which can take 5, 10, 15 seconds to display something. So the fact that we're not seeing anything on the screen right now means this machine can't even run Ultimax mode with the dead test cartridge, or in this case, the DesTest cartridge. But fear not, because there is another mode of operation that this cartridge has called the DesTestMAX-SL for SwiftLink. So let's take a look at that. So here it is, the DesTestMAX-SL, and what it is it's a novel and unique way of operating a dead test that uses a SwiftLink or compatible cartridge to send the diagnostic information over the serial port, so it's able to be run even when the VIC-2 is unable to display anything on the screen. Sending diagnostic over the SwiftLink requires no system RAM and leverages the fact that we can use a remote terminal to display and possibly buffer all fault information rather than attempt to store and display it locally. So what I have here is a Turbo 232, which is a faster version of the SwiftLink, but it's fully SwiftLink compatible. So we're going to test this out and see what DesTestMAX-SL can do for us in this situation. If we take a look down here, this is what DesTestMAX-SL will send out of the serial port. So it will test the VIC first, and then it will test other things like the checksum, and it will check the 0 page, and then it will perform a stack test, and then it will do a full RAM test as well. So we'll see the output of these diagnostics on our PC via the serial port instead of on the Commodore itself. Now, in order to use a cartridge and another cartridge at the same time, we're going to get a little bit tricky with our Commodore, and it requires basically a port expander, and I've got one here. This is called the Expander 3, and I've used this before. You've seen this in the video where I tested out the maximum throughput of a Commodore 64 and a 128, but essentially you can run multiple cartridges in a Commodore 64 at the same time as long as they don't conflict with each other using the same addresses or using the same lines like GAME or XROM. So the situation is going to be something like this. We're going to take the DesTestMAX cartridge and we're going to put it in the first slot here, and then we're going to take our Turbo 232 or SwiftLink cartridge and we're going to put it in the last slot here. Then we're going to connect up a serial port with a null modem cable, or in this case a null modem adapter, to our PC. And then we're going to connect this whole thing into the back of the Commodore, and we're going to boot it just as before and see what happens. Yeah, with this thing connected to the Commodore, it just adds an extra foot out the back. You can't even see all of the cables coming out. It takes up so much real estate on the desk. One thing I didn't mention is that this is a multi-cart, and it has an EEPROM on it that contains multiple images. So in order to use the DesTestMAX-SL, I need to change this rotary switch from 1 setting to the 2 setting here, and that will boot into the SL mode. All right, we're ready to go. The green cursor you see on the screen is my terminal program, and the blue box is the video capture. So I'm going to flip the switch on the Commodore now. And of course, we see the black screen coming out of the Commodore 64 with the white bar, and we see nothing at all on the serial port. So that indicates that it's not also just a VIC failure and that the machine is unable to run any code at all. So the DesTestMAX-SL is also unable to run on this machine. So that gives us even further indication of what could be wrong with the machine. So just for fun, let's hook up the DesTestMAX-SL to a good machine so you can see what it looks like. All right, got it hooked up to my Evo 64 here. Let's see what the DesTestMAX-SL looks like on a good working machine. Flip the switch here. And there you go. We have video output, and we also have output coming out of the serial port onto the PC, running through the diagnostic tests. If the VIC-2 wasn't able to generate any video, we wouldn't see the Desmond's C64 Max RAM test thing on the screen. We would see maybe a blank screen or some garbage, but we'd still get the data coming out of the serial port and the diagnostics would still run. So because we don't see anything on either, this C64 is very dead, and we're going to have to open it up and start taking a look at what's going on inside. Now, I've said this before, but in order to remove the top of the case without breaking the tabs in the back, don't pop the top all the way up like the hood of a car. Lift it about an inch in the front and then pull the top towards you to separate it from the tabs in the back. It's going to take a lot of wiggling. Sometimes it's really stiff, but you don't want to lift it any further than you have to avoid trying to break those tabs in the back. So I'm going to give this a good old wiggle, and then we'll be back as soon as I get this off, hopefully without any broken tabs. Well, there we go. I didn't break any of the clips, but man, was that an ordeal. This thing has never been opened up before, I don't think. It was really, really stiff. And you don't usually encounter machines that have been opened before and still have good, non-broken clips. So yeah, this one I think is all original. All right, here on the inside, we've got the RF shield that's made out of paper here, and it's normally grounded with this little foil tape, but it's come unstuck either because the sticky has completely given out or someone else has been in here before me. I didn't do this. On the inside, we have the standard assembly number 250407, which is a really common version of the C64. Nothing special about this board at all, which also makes it really easy to work on because it's well documented. We have one CIA chip in a socket and one that isn't in a socket. That's interesting. We also have a SID chip in the socket, and the VIC-2 is probably also in a socket. Otherwise, this is a pretty standard looking C64. I don't see anything obviously wrong with it. It looks like it's clean, it's in good condition, and it may have never been opened up before. Now, what could cause the dead test not to work at all? Well, as we've talked about before, the dead test boots the machine in Ultimax mode. So all it needs is 4K of RAM, and it does not need either of the CIAs, and it doesn't need any of the ROM chips, and it doesn't need the SID to work. All it needs is the CPU, the PLA, and the VIC to be working in order for the dead test to do something. Now, we could suspect the VIC too, because we didn't see anything on the screen. It may not be able to generate anything on the screen or generate the phi clock for the rest of the system, but we did see that white line on the screen. Now you're going to see that white line on a video capture board or an LCD screen, but you're not going to see that on a CRT monitor unless you've got like an underscan button on that monitor, because it's outside the viewable area of a traditional CRT monitor. Now, it could also be something talking on the bus that shouldn't be, like one of the ROM chips, or the PLA is sending out chip select signals incorrectly. So we often suspect the PLA is a problem on these machines that are black screened. And we've also seen a number of failed 6510s in the last few videos, which is unfortunate. Normally, I haven't seen that many 6510 failures in the past, but seeing 2 in a row has me jumpy. I really hope it isn't a dead 6510, because these are getting harder and harder to find. Now, there are modern replacements with the J CPU out there, but in terms of a real 6510, they're getting more expensive also. Now, what can we do? Well, the first thing we can do is we can remove the CIA chip here and remove the 6581 chip, and then retest with the dead test just to make sure that it isn't either of these that are causing the machine not to be able to boot. I'm also going to clean the VIC2. I'm going to take it out of its socket and put some contact cleaner in there, just on the in case that some of the pins have some oxidation on them. So let me get to that, and then we'll retest again with the dead test before we do anything else. Check this out. The thermal compound on the heatsink for the VIC basically is non-existent. There's just the littlest dab of dried nothing on there. This is not doing anything, so we're going to have to clean that off and replace that. All right, I've removed the CIA, I've removed the SID chip, and I've removed and resocketed the VIC2 with a little bit of contact cleaner in there as well. I've got the dead test cartridge reinstalled. Let's fire it up and see what happens. Okay, no change. We've still got the black screen with the white line, so it wasn't probably one of those chips. It might be something else in here, so we're gonna have to troubleshoot a little bit further. Now, what could it be? Well, before we dive into any of the logic itself, I've often been burnt because I didn't test the easy things first. So the first thing we're going to do is do the low-hanging fruit, because if I skip that and then it comes back to something like a blown fuse or voltage regulation, then I'm going to be kicking myself, because we should start with the easy stuff first. Let's talk a little bit about power supply theory, since we want to test out all of the power generation on the system. First of all, the power supply unit provides both 5 volts DC here, as well as 9 volts AC. And I know the power supply is good because I'm using a modern unit that has been tested and is working fine on other systems. Now, the 5 volts DC here supplies power to all of the logic on the C64 board. The 9 volts AC here is used to generate additional voltages by the system. The first thing we're going to do is we're going to test the 5 volts DC, which we can find on pins 1 and 2 of the user port, and we're also going to test the 9 volts AC, which we can find on pins 10 and 11 of the user port, which are sometimes used by external devices such as EEPROM programmers and RS-232 interfaces. Okay, with my multimeter here set to DC voltage, I'm going to turn on the system, and then I'm going to test on pins 1 and 2, making sure not to short them together. There we go, 4.82 volts, that's fine. Now I'm going to set it to AC volts, and I'm going to check pins 11 and 12, once again, being careful not to short them out. And we've got 11.60 volts on the 9 volt AC line. That's very high, but it's probably because the system isn't under any kind of load right now, and also because I'm using a Keylog aftermarket power supply, which struggles to produce the right voltage when operating in 120 volt countries like ours. What I'm going to do is I'm going to check the derived voltages from that 9 volt AC line and make sure they're okay, because those are the ones that are the most important. The 9 volts AC is rectified inside the C64, and the resultant 9 volt DC is used to power the cassette drive motor. It also is used to generate the plus 12 volts DC and plus 5 volts DC that supply the VIC2 SID and clock circuits with separate clean power from the rest of the logic. What we're going to do is we're going to test these two voltage regulators to make sure that they're outputting the correct DC values from the rectified 9 volts AC. All right, once again, I have my multimeter set to DC voltage. I'm going to grab the ground plane here, and we're going to test pin 2 of the voltage regulator. And we've got 4.94 volts on the 5 volt rail. We're going to check pin 2 here. And we've got 11.99 volts on the 12 volt rail, which is absolutely perfect. So our voltage regulators are doing exactly what they need to be doing. We've got good power for our VIC2, SID, and clock circuits. One other thing I want to do real quick is we're just going to test the fuse here, make sure the fuse is good, and it is. So all of the power that we need to test is good. We've covered that base now, so we can move on. All right, one other thing we should test is the reset circuit. That's really low-hanging fruit, and if the reset line is being held low, then the CPU will never be able to execute code. So what I'm going to do is I'm going to attach my ground here, and I'm going to attach my probe here on pin 40, which is the reset line on the CPU, and then I'm going to flip the power on, and what we should see is the reset line is held low for 1 second and then released back up to 5 volts. So let me flip the switch. Okay, yep, that looks good. Let me do it one more time. Okay, great. It looks like the reset line is working properly. Now, I have a hypothesis that I want to test about the reset circuit and the white line on the VIC2. So let me try that for just a second. One thing I wanted to test is whether or not the white line we see on the VIC is affected by a working reset circuit or not. So what I've done is I've grounded pin 40 on the CPU to the chassis here, and I'm going to keep the system in perpetual reset. Now I'm going to power it on, and we're going to look at the video capture. And we do see the white line on the VIC. So we are basically unable to determine the status of the reset circuit by the presence of that white line on the VIC. I had hoped that there may be some correlation there, but as it turns out, there isn't. So we can't assume anything about the reset circuit just because we see the presence of the white line. That's a bummer, but it is what it is. Okay, now we need to decide what to do next. Because the dead test doesn't work, we suspect it's either the VIC2, the PLA, or the CPU. We think the VIC2 is okay because it's displaying the white line, and I tested and it is generating the clock signal just fine. We don't want it to be the CPU because they're expensive to replace, so we're hoping it's the PLA. I did some other tests. I checked to make sure that none of the chips on the board were hot to touch, and everything seems fine. And I did probe some of the chip select lines with my scope, and I did see some unusual behavior on 2 of the ROM chips, which again indicates to me that it might be a PLA. So what I need to do is get the board out, remove the RF shield, and then desolder the PLA, and we're going to test with a modern replacement. And hopefully that'll fix the problem. If not, we'll have to go looking somewhere else. All right, the new socket is installed. Now we just need a PLA to test it with. And what I've got here is one of those GAL PLAs that was built and sent to me by Bob Kosty of Bob's Retro Electronics Workshop. I'll put a link in the description. But thank you very much, Bob, for sending me these so I have some spares on hand for situations just like this. Let's get this installed in the socket here. Make sure I've got the pins lined up properly. There we go. Nice fit. All right, let's hook up the power and the video. And because I haven't installed the CIA chip or the SID chip, we're still going to boot it up with the DesTestMAX cartridge here, not the SL version. Just have it set on the selector set to 1 here. Put that in like that. Cut over to our video capture, and we're going to flip the switch, but not until we've crossed our fingers. You guys ready? Here we go. Oh yes, look at that. It's doing something. All right, the machine is running through the diagnostic tests. That's awesome. Very cool. So in this case, it really does help to use the process of elimination and to follow your gut. Rule out what it isn't first, and then focus on what is most likely the possibility. And of course, the PLA is oftentimes the culprit, but we did narrow it down, and it's awesome that it was that simple. So what we need to do now is to put in the CIA and the SID, hook up the full diagnostic harness, and run through a full diagnostic to make sure that the rest of the machine is working properly. But it looks like, according to the DesTestMAX cartridge, we're passing all of the initial RAM tests, so that's good. We're already on the second test through. Ignore the time of day clock problems there. That's because the other CIA isn't installed. So everything is passing with this DesTestMAX cartridge now. So that is awesome. Very cool. I'm so happy it was something simple and it wasn't a dead 6510 CPU. Now, before we run the full diagnostic, you may have spotted this earlier, but of the 8 RAM chips on the board, 6 of them are made by Texas Instruments, and 2 of them were made by MT. MT RAM is known to be super unreliable, and I couldn't in good conscience send this machine to auction with these ticking time bombs still in there. So I removed the MT chips, installed sockets, and fitted brand new Samsung DRAM instead. All right, let's talk about the diagnostic harness for a minute. You may remember this one. I built this a few years ago, and I've been using it ever since. It's based on the traditional Commodore diagnostic harness design that goes with the full diagnostic cartridge ROM. And as you can see, it has a few ICs on there, as well as wired connections from the user port to the tape port and controller ports, as well as the keyboard. And then it has this loopback adapter here for the IEC port. More recently, there's been a new design of the diagnostic harness, and you can see it here, which has no wires. And this one was donated to me, again, by Bob Kosty. Thank you very much, Bob. And it has no ICs and no connections between any of the ports. So it's very interesting. I'm not sure exactly how this works, but we're going to test it out today. Now, if we take a look at the project page, this is something you can build yourself, and it tells a little bit about the project and what's involved and how to build it, but it doesn't really tell you what the differences are or how it works. If you dig into the comments, it will tell you that it cannot test the joystick directional controls nor the fire button, so that is definitely a difference that this harness is unable to test, but it doesn't say what else is different and why it does not need the physical wired connection to the tape port or the keyboard port. So it'll be interesting to test this out and then compare it to the full diagnostic harness that I've built over here and see if there are any differences between the two. All right, I've got the dongle harness all connected up and I've got my diagnostic cartridge here. Let's flip the switch and see what happens. Okay, great, the diagnostic is running. It's going to take a few minutes to run through the whole diagnostic here, so I may fast forward it. Now, the dead test cartridge can only test the first 4K of RAM, but the full diagnostic can test all 64K of RAM because it's not operating in that Ultimax mode, which so far we've passed all the RAM tests, which is great. It means the new RAM that I installed is working and all the other RAM as well, so that's great. SID chip is working, that's excellent. Okay, so all of the tests have passed with this dongle harness, We know it doesn't test the directional or fire buttons on the joystick. Don't know what else it doesn't test. So what I'm going to do is I'm going to switch over to my full diagnostic harness and rerun the tests and just see if anything is different. All right, I've switched over to the full harness. It is kind of a mess with all these wires everywhere, but let's fire up the test again and see if anything is different this time. Okay, it's off and running. I'm just going to fast forward this because we don't need to see the whole thing. Okay, great. So we didn't find any problems that weren't exposed by the wireless diagnostic harness, so that is good. Though I'm still unsure if there's anything really important that this isn't testing. If you guys know anything about the wireless harness, please let me know in the comments. But the good news is here is we have a fully working C64 with no issues whatsoever. So this thing is good to be packaged back up. So let me get to the cleaning next. And once again, I've jumped the gun, as I tend to do, and before we move on to the cleaning, we really need to test the keyboard, because if that doesn't work, it's not going to be a very useful machine for anybody. So to that end, I have loaded up the 64 Doctor cartridge image here, and I've got the keyboard connected. Let's see what we've got. This is just a basic keyboard test, where we can type on the keys, and it will highlight the ones that are working. And so far, oh, okay, Q is working. All right, so not a very good result. Let me see if it just requires a little more force. Yes, okay. So if you push harder, all the keys seem to be working. You just need to really hammer on them. So that is indicative of just dirty contacts, which means we've got to take this thing apart and clean the membrane, which means dozens of little tiny screws. So let's get to that. Okay, I think that's all of them. Last but not least, we have to deal with the caps lock key here, which is soldered into place. So let me get my soldering iron out and we'll get that disconnected. All right, with that done, we should just be able to remove this backing plate here and expose, yep, there we go, the PCB. And oh boy, yeah, it is dirty. I'll show you that in a second, but we're going to be able to clean the contacts on this PCB here. And then we've got the plungers here for each of the keys. And I'm not going to try and clean those because I don't want to damage them with any kind of chemicals. You probably could wipe them off with some water, but I wouldn't use anything else on these. I don't want to degrade the rubber material here. So I'm just going to set this off to the side. Let me show you this up close. So yeah, there you can see how dirty the contacts on this PCB are. We just need to get in there with some IPA and wipe down each one of these contacts until it's shiny and clean, and then the keyboard should work perfectly again. Yeah, there's no shortcut to this. You've just got to clean each contact one at a time, and I'm just going to put a little IPA on a Q-tip here, and we're just going to wipe down each one until it's clean. Already looking a lot better. So I'm just going to do the whole thing here and stand by. Yeah, besides looking at how clean they are now, if there's any question about how dirty it is, just check out this Q-tip. It is already covered in brown filth. So let me get another one and we will continue on. Another trick, if you have a particularly stubborn, dirty contact, is you can use one of these white erasers and just gently scrub the pad, as long as you then use alcohol to clean it off once you're done. Yeah, see how much better they look now? Reassembly is just the reverse of what we've already done, so let me get it put back together and we will test it out again. Now I know I said I wasn't going to clean the rubber plungers here, but they're pretty dirty and I think I should clean them. So I'm just going to use a little more IPA on a Q-tip and just get in there and clean each one of these as well. I'm also really glad that I did clean the rubber contacts because they were filthy. All right, I've got it all back together again. Let's give it another test. Got the 64 Doctor here again. Just the lightest amount of pressure now. Look at that, it's working perfectly. Beautiful, working great. We can't auction off a dirty computer, so I think it's finally time to get to the cleaning. All right, we're making good progress now, but before we can reassemble anything, I want to remove this old thermal compound from the VIC-2 as well as the heatsink on the RF shield here. For that, I'm just going to use a little bit of IPA on a paper towel. Just remove the old stuff. That is caked on and dry as anything there. Wow. That came off a lot easier. Great. I think I'm going to go one more time, just to make sure that I've got it all. Okay, that's as clean as it's going to get. Let me also clean off the SID, even though it's not dirty, and the CPU, because I'm going to put some heat sinks on here, and I just want to get any dust or lingering debris off of here. Finish it off by giving them a wipe down with a microfiber towel. Just get any debris off. There we go. Great. Now just a little dab of thermal compound. A little bit will do it. Doesn't take a lot. It's good. And now we can put the can back on. There we go. Excellent. Next, I want to install some heat sinks on the CPU and the SID chip because these tend to run hot. And I've got these little heat sinks here with the 3M thermal adhesive pads already installed. So we just peel them off like that. And there's one. There's two. And there's three. Very nice. The case is dry, so we're ready to start putting things back together now, but when I was inspecting the work, I noticed this. The clear plastic cover has these fine scratches on it, and I suspect I did that with the Scotch-Brite pad when I was cleaning it. So what I'm going to do is I'm going to take some plastic polish here, and I'm going to try and clean this up and make this nice and shiny once again. All right, that is a lot better. Now, it's not perfect, but it's much better than it was, and there's already patina just by virtue of this thing being 40 years old. So I think that is just part of the charm of an old system like this. I've got the board reinstalled in the lower case, and I've got the keyboard reinstalled in the upper case, and all that's left to do now is reattach the LED and keyboard harness and secure these two parts together. Of course, always remember to back off the screw until it clicks before driving it in. That way you make sure the threads are all aligned and you're not cross-threading anything. And there we go. Now that it's all back together, we should probably test it out with a game just to make sure that it's all working properly. Whoops! Sorry, dude. Well, maybe next time.
Oh yeah, this 64 is working great and looking sharp. I'm really pleased with how this repair and restoration turned out, and I hope that whoever ends up winning this auction is happy with this machine as well. The keyboard cover is a really neat addition and gives the Commodore a unique, period-correct charm. Of course, after putting in all this work, I really don't want to let this 64 go. But hey, it's for a good cause, so don't be shy about bidding. Before it changes hands though, I think the only proper thing to do is to put it through its paces and spend a few hours playing some games and demos. You know, to make sure it's reliable, and absolutely not because I'm slacking off editing this video.
Now, what good is a restored C64 without a modern power supply, right? So what we've got here is a brand new, never used Electroware power supply, which is kind of the de facto standard power supply people are using these days, from C64PSU.com. I bought this specifically for this build so that the new owner will have a nice modern power supply to go with their C64 and not have to worry about any old bricks frying their chips. So there you go. Whoever wins the auction will get this brand new Electroware PSU to go with the C64. As a special bonus, I wanted to include a brand new set of keycaps from last year's Indiegogo campaign. I'm going to let the winning bidder decide on a complete set in whatever color combination they want. The keycaps on offer here are all unique colors that weren't available during the Indiegogo campaign and are sold out of the CBM Stuff store. I think these keycaps would go really well with one of the replica 64C cases from Individual Computers or one of the new bread bin cases from the current Indiegogo campaign. Unfortunately, the timing didn't work out and these cases haven't shipped yet, nor do I have any others on hand to offer. Still, the winning bidder may eventually want to transplant this board into a new case and use one of these keycap sets with it. Everybody's got their own tastes. That's why I'm leaving it up to the winning bidder to decide, but maybe you want to do something like this. Or this. Or even this. I do want to thank Jim Drew for supplying these custom colors so I could make them available for this auction. Just to sweeten the deal for the winning bidder, I'm going to include some Retrobit swag. Here we have some vinyl stickers that I had made up for VCF Midwest. This is a handmade kitchen magnet. Check out those scan lines. And then we've got a Retrobits business card. You can keep it with the C64 or you can toss it in the bin, whatever you want to do. Well, I think this restoration came out great. And I think the new owner of this machine will be very happy with it. And hey, one day when I'm YouTube famous, you can point back to this video as the place it all started. So make sure you bid accordingly. The Befriending Scheme is a worthy cause that has direct and immediate impact on the lives of adults with special needs or learning disabilities who may otherwise often experience isolation. Your generosity and outpouring of support last year was amazing, so let's see if we can't top it this year and raise £15,000 for this charity. A link to the auction is in the description. There's also a direct link to the Just Giving page if you prefer to donate directly to the cause. I hope to see you all at the live stream on October 19th, so make sure you enable notifications using the event link below. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.